Okay, my final binomial example is on page 17, and it is number 11. It says this particular burglar alarm system has 6 fail-safe components, and each one has the probability that it fails as 0.05. So that's my P, and the 6 here is my N. So way over here on the side, I like to write out that this is a binomial model with 6 and 0.05 as the probability of success. And then we should like this language, right? This says exactly 3 fail, which means that we want to use the binom PDF when we're given exactly 3. So I want to go ahead and, hold on, I'm trying to fix this iPad here. I want to go ahead and use the binom PDF, and then we've got 6 fail-safe components. Remember, I know that the wording here for P is like the probability of success, but in this case, we're asking that exactly 3 fail, so the fact that this is a probability of failure is just fine. And then the exactly is 3, so we want to substitute the 3 in there. And I'm going to leave this to you to find in your calculator using all the other resources I've given you. I'm going to take that out to 4 decimal places, 0.0021. All right, this is language that we haven't seen yet, right? Fewer than 2. I'm going to help us out here. Fewer than 2, right? That's actually like 0 and 1. So I want to think of that as 1 or fewer, because that's the language we used when we described how to use the binom CDF. So if we do the binom CDF, we can do 6 fail-safe components. The probability they fail is 0.05, and we want only 1 or 0 to fail. So this last number, if you can write it correctly, should be the number 1. Okay? My dog is freaking out. He loves when I'm home alone and he can bark at me. Oh, and there goes the other one. Isn't this fun? Okay. Jackie. It's okay. All right. I don't want any. 9, 6, 7, 2. Guys, there's got to be another dog. Okay. I'm going to help us out with Dex. Come here. Come on. Chill. Get down. Jack. Sorry. I'm sorry, guys. Okay. Woo, let's try again. Between Jackie. Come here. Ah. Come here. She's 13, so she can't really hear, so she just barks at everything. Okay. Jack. Between 2 and 5 fail, and this says inclusive. So if we make the same kind of chart, I'm going to move down here so we have plenty of room. But if we make the same kind of chart as before, we said it'd be like 1, 2, 3, 4, 5. And we like to box in the things that are included. Remember that before we had to start like, oh, Jackie, at the first thing that's not included, or that is included. So we begin with the CDF at 5. And then remember, we want to remove all the stuff that we don't want, which in this case is 1 and 0. So we will subtract the CDF at 1 so that we take away the 1 and the 0. So let's set this up in one line. So we have 6 fail-safe components, 5% chance they don't work, and in this case we're going to start with 5 because that gives us 5, 4, 3, 2, 1, 0. And then we're going to take the binom CDF and we're going to subtract the CDF at 1 because that takes away 1 and 0. And remember, like the last example, we can actually do this all at once in our calculator and get this particular answer. And now I want to follow up with one more example of practicing the mean and the standard deviation. So the mean here would be 6 times 0.05, which gives us 0.3. And then what are these? These are components. And then remember that if we want to find Q, we have to subtract P from 1. So we take our N, we take our P, and then we make sure that we do 1 minus p to find this other value, which would be 0.95. And if we plug all that in, we end up with, if we take that and then take the square root of it, it's approximate. So it's 0.5339 components. And then the only thing I think I left off that I'm going to add on here as an example is like a part E. Find the probability that, right? And then I want to do something like more than 3 fail. Okay, so I'm just making this up because I want to do this together, and then I'll put it in my calculator and get us the right answer. But I want to think of like what more than 3 means, right? More than 3 is 4 or more, if you agree. If we want to be inclusive, right? More than 3 is 4 or more because 3 can't be included. Which means that we don't want anything that's less than 3 or less, excuse me. So we should take away the probability of 3 or fewer. So we start with 1, or this is 100% of the events, right? And subtract the ones that we do not want. So in order to get 3 or fewer, we would use a CDF. So this would look like 1 minus the binom CDF, and then we have 6 fail-safe components, a 5% chance they don't work, and we want to get rid of 3, 2, 1, and 0, which is going to leave us with 4, 5, and 6. And I have not even taken out my calculator because I've been using the solutions. So let me do this one with you. So we go to the binom CDF, 6.05 is P, and the X value, or K in my case, is 3, and I'm going to do 1 minus that answer. Okay, so it's scientific notation, of course it is. And then this is great practice because the calculator actually shows me this. 8.6 E negative 5. But what that is this. That's scientific notation for this. 1, 2, 3, 4 zeros, and then 8, 6. Okay? This is the same as 8 times 10 to the negative 5. All right? Or 8.6 times 10 to the negative 5. Okay? I just want everybody to understand the output from their calculator because some of the answers in this particular unit can be very, very small because we're dealing with such tiny probabilities to begin with. Okay. Please find me online on Zoom during the hours that I post for when I'm available. I really hope that this content, the way I'm presenting it, is something that can be helpful to you. Good luck.